Okay, so this is continuing on with net ionic equations. There are several rules that you need to internalize. So the first one I want to talk about is if you have anything that is a gas, a pure liquid like water, or solids, those are not going to become ions in your complete ionic or your net ionic equation. So they'll just stay as gases, liquids, or solids. If you are forming carbonic acid, so H2CO3, as a product, that will immediately decompose into liquid water and carbon dioxide gas. So don't try to find that on your solubility chart. That's going to stay when the carbonic acid gets made. It'll immediately break down into water and CO2 gas. And I think I have an example of that for you. Same thing with ammonium hydroxide. If you see that as a product, go ahead and decompose it into liquid water and ammonia gas. Okay? All right, so this next rule, or the next three rules, deal with metals reacting with water. So if you have a metal, like a group 1 metal, reacting with water, it is going to form as products the metal hydroxide and hydrogen gas. So these three examples here show metals reacting with water, and they will form as products hydrogen gas, which you're not going to dissociate that, and then they'll also form the metal hydroxide. And as long as the hydroxide is a group 1 metal, or calcium hydroxide, barium hydroxide, strontium hydroxide, those will be aqueous and they will make ions. If you have a metal hydride in water, it'll make the same products as a metal in water. So if you have sodium hydride in water, you'll make hydrogen gas and then sodium hydroxide. Again, the hydrogen gas is not going to make ions, but the sodium hydroxide will make ions. It'll be aqueous. And then last, you have metal oxides. So if you have a metal oxide reacting with water, they'll still make metal hydroxides, but they will not make hydrogen gas. And so your potassium hydroxide, sodium hydroxide, and calcium hydroxide, all of those will split or dissociate into aqueous ions, but magnesium hydroxide will not separate into aqueous ions. Okay, continuing on with the rules, if you have a metallic chlorate like potassium chlorate or lithium chlorate, sodium chlorate, if the problem that you're reading mentions something about it being heated strongly, this triangle over the yield arrow means heated, and it'll decompose into a metal chloride and then oxygen gas. So since you're starting with a solid metallic chlorate, you'll make solid metal chlorides and oxygen gas. So again, those will not break down into ions. So you'll have no net ionic equation there. And then the last rule is when you have a metal carbonate and it's strongly heated, it'll decompose into a metal oxide and carbon dioxide gas. So if you have something like calcium carbonate, which is a solid, and you heat it strongly, it'll decompose into solid calcium oxide and carbon dioxide gas. So again, you would not have a net ionic equation with this reaction. In terms of acids, and I typically don't mark chloric acid as a strong acid, most of the acids that you're going to deal with in your equations are going to be strong. Strong acids completely dissociate. So this picture down here shows an acid being dissolved in water, And if it's a strong acid, it will almost 100% dissociate into positive hydrogen ions and then negative ions of either the nonmetal that was in the acid or the polyatomic ion that was in the acid. If you have a weak acids, when they're put into water, they do not dissociate to an appreciable extent. So you'll have only 1 to 2% of your molecules will dissociate into positive and negative ions. So if you have a weak acid, if you have a weak acid like acetic acid, it's weak. It's not in this list of your 6 strong. So if you have a weak acid, it will not ionize, it will not make ions in solution. So do not split it up into ions in your complete or your net ionic equations. It will still dissolve in water, it just won't make ions. So you'll still put an AQ beside acetic acid, but do not split acetic acid into ions. And I have an example of that for you. So when I say split into ions, what I mean is that if you have an ionic solid that is aqueous, what will happen is the water will come in, and water is a polar molecule, so the oxygen end has a slight negative charge, the hydrogen ends are slightly positively charged. And so this ionic solid, in this case it's going to be sodium chloride, not only will it dissolve in water, but once it is in the water will pull apart the individual ions from each other. When we get to thermochemistry, we'll talk about from an energy standpoint how this happens, but I want you to note that when you dissociate a compound into ions, water literally surrounds each of those ions. Okay, so they're solvated, and if you're dealing with water, they're hydrated ions. Notice how in the positive ion, water is interacting with that ion at its oxygen end. Whereas with your chloride ion, since this is a negative ion, water will interact with the chloride ion at its positive end, its hydrogen end. So notice the orientation of the water around each of the ions. Okay, actually I'm going to pause here.